Alright, in this section here we're going to be talking about absolute value inequalities. Well, let's get started with an example. We have the absolute value of x is greater than or equal to, we'll say 2. So whatever we plug in for x and we take the absolute value of it, it's going to have to be greater than or equal to 2. So much like the absolute value equations and what did we work last? The absolute value equations, boy, I tell you, my memory's going. In the last section, I guess it was the absolute value equations. Okay. We better get started. What I'm going to do here is drop the absolute value. Alright, keep our inequality. Now, we got two words that we're going to be working with here, and that's the word and the word or. Now, this is how I remember it. The word or has the letter R in it. As you can see, there's no letter R in the word and. Pretend that this inequality here, this greater than or equal to, is an arrow, and it's pointing to the right. It's an arrow pointing to the right. So when you see this, you know that we're going to be working with the word or. And if our inequality is less than, then because it's not pointing to the right, it's got to be the other case, right? So or goes with right, and then this one here follows with and. Okay, so we got x is greater than or equal to 2. Because it's pointing to the right, we use the word or. X, now we're going to flip the inequality this time and throw a negative out in the front of 2. Well, we're done. This is as far as we can go here. Now we can write this another way to show the solution set, but what we normally do here first to kind of get a visual on this, I'm going to attempt to draw a number line here. Let's attempt a straight line. Okay, I'm going to plot 2 on the number line, and we'll just put it right here, and then I'll say negative 2 is over here, and of course 0 is somewhere in the middle. Now this includes 2, so I'm going to put a solid dot here because it includes 2. In fact, I think I'll use a different color. Right? Ooh, that didn't really show it very well. Okay. Well, it's everything to the right of 2. And then this one here says x is less than or equal to 2. Solid dot because we include negative 2. And everything less than or equal to negative 2. Now I'm going to write this in where we have this interval notation. This is our solution set. You may have not ever seen this before. That's okay. I'll explain it to you here in just a second. Alright, so this is an infinity sign, and this means we're going out to the left and we're going on forever as we go towards negative infinity. And of course I have a parentheses here because that means we don't ever reach negative infinity. I have a bracket here, and that means because we are including negative 2. So everything between negative 2 and out to negative infinity. And this is the symbol for union. So if you don't know what that is, you might want to check out the sets section. And then this bracket here includes 2 and out to infinity. And the word or means that I can pick a number either in here or in here and plug it into this, and it will be true. Okay, we're working absolute value inequalities. Okay, so this is going to be much like the last problem. We have the absolute value of x is greater than 7. So we want to find the solutions to this inequality. So the first thing I'm going to do is I'm going to drop the absolute value bars and just rewrite it. Okay, so we have x is greater than 7. So that's going to be one solution. Now, remember this is like an arrow. We see this like an arrow and it's pointing to the right. So that means we're going to use or. Okay? Now I'm going to rewrite this part here, what's in absolute value bars. But now this time I'm going to flip the inequality and make this negative. Whoops. Forgot and left the R off. So our solutions is x is greater than 7 or x is less than negative 7. So now what I'm going to do, so we can get a visual on this, draw a number line. I'm going to, let's put negative 7 here, and we'll put 7 over here. And let me use a different color here. So we don't include 7 and we don't include negative 7. So that means I'm just going to put a circle here. Okay. So this says x is greater than 7. So that'd be all the values that are greater than 7. Like for example, 7.5 or 100 or 99, right? And then this one here says x is less than negative 7. So that'd be everything going in this direction. You can choose any number to the left of negative 7, except you can't choose negative 7. But let's just say we did choose negative 7. If I were to plug negative 7 up here, so I put negative 7 in, we'll just do it right over here. So negative 7, what is the absolute value of negative 7? Well, the absolute value of negative 7 is 7. But the question is 7 greater than 7? And the answer to that is no, 7 is not greater than 7. Okay? If this were an equal sign right here, a line under here, then we could say yes, because 7 does equal 7, but it doesn't. So no, that's not greater than 7. Now remember, we can write this, our answer, in interval notation. We're going out to infinity. We always use a parentheses, comma, up to negative 7. We use a parentheses because we don't include negative 7. And I'm going to take the union because we're joining two sets together here. 7 to infinity. Okay, let's look at another one. Alright, let's look at this one here. We have the absolute value of x is greater than negative 7. So we drop the absolute value bars. Now remember, we're pointing to the right, so we use or. And we rewrite what's inside the absolute value bars. This time we flip the sign. We throw a negative out front of this, but a negative and a negative is positive. All right. And as you can see, if I were to put negative 7 here and 7 here, x is greater than negative 7, so everything to the right. X is less than 7, everything to the left. But because we're using or, that means everything from negative infinity to positive infinity. Okay, here's a similar one. We have the absolute value of x is finish that off, is less than or equal to 10. So we rewrite what's inside the absolute value bars. So basically in the first part here, we're just dropping the absolute value bars and rewriting it. Now we notice that the inequality here, remember I said look at it as the head of an arrow and it's pointing to the left. So this time we're going to use the word right. Did I say right? I meant the word and. My goodness. Okay. So this is going to end up being x is less than or equal to 10 and x. Now we're going to flip the inequality and throw a negative out in front of 10 here. So there's our solution. X is less than, all values less than or equal to 10, and all values greater than or equal to negative 10. Now, what exactly does this look like on the number line? Well, let's just draw it out. So I suggest learning this for the first time to definitely draw out a number line. So let's plot number negative 10 here, and we'll put 10 right here, and I'll use a different color. Okay, so x is less than or equal to 10. So now we're including 10 here, so let me just put a solid dot. It's everything less than or equal to, so everything to the left of 10. This says x is greater than or equal to negative 10. I'll use a different color this time. And remember we're including 10, so I'm going to put a solid dot here. So it's, that's actually supposed to be a solid dot here. Okay, everything greater than or equal to negative 10. Okay, we're using the word and. So that means when we pick a number, it must satisfy both this inequality and this one, right? So in other words, if I were to pick 11 and I plugged it in over here, the absolute value of 11 is not less than or equal to 10. The absolute value of 11 is 11. 11 is not less than or equal to 10. So it has to be, because and means it must satisfy both this inequality here and this one here also. So that means we're going to be left with, I'm going to use a bracket here because we include negative 10, comma, and 10. And we use brackets because we include parentheses if we don't include 10, right? So it's everything between negative 10 and 10. Okay, let's say we had the absolute value of x plus 5 is less than 10. We'll use 10 again. Now this time we've got to get this in standard form, and that is we're going to take this constant here over to the right hand side of the inequality, and when we do, because it's a positive, we take it over to the right, it becomes negative. So now we have the absolute value of x is less than 5. Now you should know how to work this one out. I'm going to go ahead and give you the answer, and you try working it out and getting this interval here, negative 5 and 5. Alright, so it's important that you try working these out on your own. Alright, we're going to work our way towards some little bit ones with a little bit more difficulty. Of course we have to do that. Okay, we're going to have the absolute value of x minus 1 is greater than or equal to 5. So we drop the absolute value bars, rewrite the inequality, and just rewrite 5. So we're just rewriting it, except dropping the absolute value bars. Now let me say this. Remember that this inequality looks like the head of an arrow, and it's pointing to the right. And that means we're going to use the word or. So remember, the letter R in or should remind you of the word right. Okay? And then I'm going to rewrite this. So we have x minus 1. We're going to flip this inequality and throw a negative out front of the 5. Okay, so let's work this one here. So just pretend this is like a regular equation and we're solving for x. So because we have a minus 1, I'm going to take it over to the right hand side and it becomes a plus 1. So at this point in the game, I'm skipping all these intermediate steps for the most part. Alright, you should go back to solving linear equations if you want to figure out how this negative 1 became a positive 1. Okay. Alright, so we have x is going to be greater than or equal to 6. I'll just follow the or down. Do the same thing here. Less than or equal to negative 5. Take this minus 1 over to the right so it becomes a positive 1. And we have x is less than or equal to 6. Wait a second. Let me look at this again here real quick. We got 6. Okay, what did I do wrong here? This is definitely not 6. Just looking back at my work going, something's not right. Alright, negative 5 plus 1 is negative 4. So you probably caught that before I did. I hope anyway. Now let's draw a number line so we can get a visual on this thing. At least attempt to draw a horizontal line. Okay, so I'm going to put 6 here. Just arbitrarily throw a 6 in there, and we'll throw a negative 4 in right here. How's that? We're including 6, so I'm going to put a solid dot. And actually, how about if I use a different color? Alright, so solid dot, it's everything greater than or equal to 6. Right, and negative 4, solid dot because we include it. And everything that's less than or equal to negative 4. Alright, well let's go ahead and write out our interval. So it's going off to infinity. To the left, it's supposed to be an infinity symbol. So negative infinity to negative 4. We got a solid dot here, that means we include it. Okay. And we're going to union that with 6 to infinity. So you may not be actually using the union symbol and doing it exactly like this, but this is about the most proper way of writing this solution set. Okay, moving right along. This next one here will be a little bit different. We have the absolute value of 3 minus 2x. And we're going to say that that's going to be less than or equal to 5. So we go through the same old procedures. Just drop that absolute value sign and rewrite. Now remember, the inequality looks like the head of an arrow and it's pointing this time to the left. So we're going to use the word and. If it was pointing to the right, the R in right tells us that, or reminds us that we need to use the word or because there's an R in or. Okay. So rewriting what's in the absolute value bars, and this time I'm going to flip the absolute value, flip the inequality, and then throw a negative out in the front. So now we've basically just have an equation, and we're just solving for x in this problem. So what I'm going to do is, because what am I going to do? You know what? I'll go ahead and take the 3 over to the right, and because it's a positive 3, when I take it over to this other side, it becomes a negative 3. So we have negative 2x is less than or equal to 5 minus 3. Now I'm going to simplify this down a little bit more, and that just becomes a 2 there. Now we got to get rid of this negative 2, and in order to do that, I think I'll use a different color. In order to do that, I'm going to multiply both sides by a negative half, negative a half. So we have a negative a half times a negative 2. And a negative a half times negative 2 is 1. But we're not going to write 1 here. We're just going to write x. But we multiply through by a negative, and that's going to cause this inequality sign here to flip. Alright, so we're going to flip that. We have a 2 times a negative a half, so that's going to give us a negative 1. Okay, we're good on that. Let's look at this one. So I take the 3, I bring it over to the right, so we end up with negative 2x is greater than or equal to negative 5 minus 3. Now we're going to simplify this down a little bit. We have negative 2x is greater than or equal to negative 8. Now I'm going to multiply through by negative a half to both sides, just like I did here. And so we know that a negative a half times negative 2 is 1. So we're going to be left with just an x, but we have to flip this guy now because we're multiplying through by negative. It's the only time that you flip this inequality is when we're multiplying through by a negative. And so we have a negative 8 times a negative a half. And of course we've got to simplify that down. And so we're left with x is less than or equal to, and a negative times a negative is positive, and half of 8 is 4. Okay, so here's our two solutions. Now remember, we're using the word and up here, which you can barely see on the screen, I think. And so let's draw this out. X is greater than negative 1. Right, and here's a 4. X is less than or equal to 4. Alright, and because we're using and, we're going to use brackets and everything in between negative 1 and 4. So we're moving right along. Hopefully you're catching on to this stuff by now. We're going to have 2 times the absolute value of x plus 7 is less than 8. So we got to get this thing in a standard form, and that is we need to get just the absolute value bars over here. We've got this 2. So what we're going to do is we're going to multiply both sides by a half. So half times 2, and then we're going to come over here and multiply this side by half. So a half times 2 is 1. So we're going to be left with x plus 7. And then half of 8 is 4. So now we're in this form that you should have seen before. So why don't you go ahead and try to work this out, and I will just go ahead and give you can pause the video, try to work this out, and I'm going to write the answer right here. And you try to gravitate towards this answer, right? Alright. Let me go ahead and give you another one. And you try to find the answer to this. I should say the solution to this inequality. Right, so go ahead, pause the video, work this out, and I'm going to write the solution right over here, or I'll just write it right down here. Okay, negative infinity to negative 5, enclosed in parentheses, union 1 to infinity. Okay, I should have these exercises actually on my website. Hopefully I'll have them on there. Check that out at mathfix.com and go under beginning algebra and then absolute value inequalities. Alright, thank you.